Hello students, welcome to Examora, your smart way to prepare for the exams. Today we are discussing the topic patterns in mathematics. This is one of the most important and easy scoring topics in exams. So in this video, we will fill in the blanks, learn important number patterns, practice missing number questions, and solve exam level word problems. So make sure you watch till the end because these questions are very important for the examinations. Fill in the blanks. Choose the correct option from the brackets. Question number 1. The branch of mathematics that studies patterns in shape is called algebra, geometry. As we all know, algebra uses symbols. Geometry specifically focuses on the properties and relationship of shapes and space. So the right option is geometry. Second question, the numbers 1, 4, 9, 16 are examples of dash number, triangular number, square number. So the number which is 1, 4, 9, 16, 25. These are the result of multiplying a whole number by itself. So 1 square equals 1, 2 square equals 4, 3 square equals 9. So all these are square numbers. So the option is square numbers. Question number 3. Adding consecutive dash numbers starting from 1 result in square numbers. The adding consecutive dash number starting from 1. The set is square number. This is one of the property. For example, the number 1 plus 3, that is equal to 4. 4 is a square number. 2 square is 4. The next odd number, 1 plus 3 plus 5, that is 9. 9 is a square number. 3 square is 9. So similarly, if we add 1 plus 3 plus 5, next odd number is 7. That we get 16. 16 is a square number. 4 square is 16. So adding consecutive odd number, we get square number, not even number, odd number, we get square numbers. Fourth question. Write the next number in the sequence 2, 3, 5, 8, 13. So these patterns are following Fibonacci patterns. So this pattern states that where you add the previous two numbers together, you get the next number. It can do the examples. Fourth question, 2 plus 3. 2 plus 3 equal to 5. Here the 5, the next number is 5. Similarly, we can do 3 plus 5, that is equal to 8. The next number 8. Next we can do 5 plus 8, that is 13. So here 13 is here. So next we have to find out the next pattern, that is 8 plus 13. 8 plus 13 equals 21. So the next sequence or pattern is 21. Okay, this is Fibonacci patterns. Question number 5. A polygon with 6 sides is called, we already know the 6-sided figure, that is hexagon. Question number 6. The number of edges in a sequence of regular polygons is equal to the number of sides and dash. In a simple polygon, the number of sides, vertices, and interior angles are always equal. So, for a polygon, the number of edges is equal to number of its sides and vertices. Vertices, also known as, also we can write as corners. Or corners. Seventh question. In a complete graph with the 3 dots, K3, there are dash lines connecting them. So in a K3 graph, every dot connected to every other dots forming a triangle with the 3 lines. So these dots are connected with the 3 lines and forms homoline 1, 2 and 3. So 3 lines. 8th question. The sequence 1, 3, 6, 10, 15 is called sequence of dash number, triangular number, square number. So the numbers 1, 3, 6, 10, 15, these numbers can form an equilateral triangular pattern. For example, 1, The next number pattern 1 plus 2. Counting numbers equals 3. So next to counting number 1 plus 2 plus 3. That is 6. They are forming a series of sequence that is triangular series called triangular numbers. So these numbers are representing triangular set of numbers, not square numbers. Write the next number in the sequence 0, 1, 1, 2, 3, 5, 8. So this rule also explains the Fibonacci sequence that we discussed earlier. This number Fibonacci sequence starting with 0. So the number 0 plus 1, the next number 1, 1 plus 1, the next number 2, 2 plus 3, next number 5, 5 plus 8, the next number. We have to find out the next number, asserting the Fibonacci sequence. That is 5 plus 8, that is 13. So the series of number coming after 8 is 13. Okay. 10th question. The sum of counting numbers up then down always result in dash number. So we can write 1 plus 2 plus 1. That is equals 4. The next counting number 1 plus 2 plus up, that is 3, plus down 2 plus 1, that is 9. Here we get answer 9. So we can do one more steps. One more, 1 plus 2 plus 3. So up 4 plus next down 3 plus 2 plus 1, that is equals 16. So 16. All these are sets of square numbers. So the sum of counting numbers up then down, we get square patterns of numbers, not triangular pattern, square patterns of numbers. So let's move to the next sets. Write the missing numbers in the following patterns. The first one, 3, 3, 3 dash 3. So we all know that the numbers is constant, says the same, so the answer is here 3. Next 5, 10, 20 dash 80. Here the number 5, 10, 20 dash 80. 5 into 2, that is 10. The next number 10 into 2, 20, 20 into 2, similar. 14 and 14 into 2, 80. So the rule is multiply by 2. Here that rule, multiply by 2. By 2. Okay. So third question, 2, 4, 6 dash 10. Here the rule is 2 plus 2, 4, 4 plus 2, 6. So here the number 8. Number 8. The rule is add 2. Fourth one, 1 dash 5, 7, 9. Here also same. This is even set of number, the previous one. This is the old set of number. The rule is also adding 2. The next number. So here 3. 51, 12, dash 36, 48, 60. See here, we can do the one difference. First we can do the difference. 36 and 48. So by doing 36 and 48, we get the difference of 12. 40 and 60, also difference of 12. So same like here also. 12 and this missing number, also the difference of 12. So we can add 12 plus 12. So the number will come 24. So the rule is add 12. 61, 3, 9, 27 dash 243. C, 3, 9. So next number is 27. So 3 into 3 is 9. 9 into 3, 27. We can do 27 into 3. Just do 27 into 3. The answer we get 81. We can check for the next two number. 81. 81 into 3. If after doing this, we get 243. So the number here it comes 27 into 3. 27 into 3. That is 81. So here the rule is multiply by 3. Okay, clear? 71, 50, 41, 32, dash 14. So the numbers are going like decreasing order. So we can do the difference. First 50 minus 41, the difference is 9. 41 minus 32, the difference also 9. So the next number also difference become the difference like 9. So the next number is 23. We can check 23. 32 minus 23. Here also the difference. We get difference 9. So the rule is subtract. 9. Okay. 8 version 137-21. So here see, by taking the difference 1 minus 3 minus 1, that is 2. 7 minus 3, that is 4. Here coming the difference, here 2. 1 minus 3 is 2, and here comes 2, and 7 minus 3 is 4. Likewise it is going. So the next number will be 6, 2, 4, 6 plus 6. The difference increases by 2 each time. So the next number 7 plus 6, 7 plus 6, that is 13. Let's check with the 21 also. After 6 plus 8 plus 8, 13 plus 8, that is 21. Yes, the answer is right. The difference, here the rule, the difference, and the difference increased by 2 each time. The decreasing the difference increased by 2 each time, that is plus 2 plus 4 plus 6 plus 8, etc. Like this pattern, this is going. Okay, clear? Let's move to the 9th question. To 618-162. So we can check by this first set of numbers while multiplying 2 into which number we hit 6. 3. So 2 into 3 is 6. 6 into 3 18. So the patterns are going by multiplying by 3. So we can do 18 into 3, that is 54. So similarly we can do with the 54 into 3, let's check. As the answer is 162, so the pattern is correct. So the rule is multiply by 3. Okay. The final one, 181-64-36. So let's check. This is also going by decreasing order. What we can see, the number 100, 81, 64. All these are perfect squares. 10 square is 100. 9 square is 81. 8 square is 64. So similarly, next number B, 7 square. 7 square, what is 7 square? It's 49. Yes. Next, 36, the number is 36, so 6 square. So these are perfect squares in decreasing order. The rule is perfect squares. Perfect squares in decreasing orders. Orders. Okay? So practice these questions. This will help you to improve. If you get stuck or have any doubts, drop your questions in comments. So next move to the board problems. Question: which sequence do you get if you start with 1 and keep adding 4 to the previous number? Write the first 5 terms. So to find the first 5 terms, start with 1 and repeatedly add 4. So we can start with 1. First start with 1, then we can add 4 to that number. 1 plus 4. That is 5. Next number, 5 plus 4. We get 9. So the next we have to add 9 plus 4. That is 13. Again, 13 plus 4. 13 plus 4, 17. So, like this, to find the first 5 terms, start with 1 and we have to add repeatedly with 4. Okay? So, the first 5 terms are 1, 5, 9, 13 and 17. So, you can write here 1, 5, 9, 13 and 17. Okay, clear? Next question. Which sequence do you get when each term of the sequence of even numbers is multiplied by 3? For this question, first identify the sequence of even numbers. So even numbers are 2, 4, 6, 8, 10, etc. Now multiply each term by 3. So here the question multiply by 3. So we can multiply these sets of even numbers by 3. First number 2, 2 into 3, that is 6. Next even number 4, 4 into 3, that is 12. Next even number 6, 6 into 3, that is 18. Next, 8 into 3, 24. 10 into 3, that is 30. From this, we get the sequence 6, 12, 18, 24, and 30. So, also they're asking to explain the rule. So this rule is the sequence consists of the multiples of 6. All the numbers are multiples of 6. So we can write here multiples of 6. Okay. Multiples of 6. All these numbers are multiples of 6. Next question. Draw the next 2 shapes in the given pattern. Write the number of dots used to draw the shape below it. Here the pattern shows dots arranged in triangles, where each new shape adds a row of dots at the bottom. So the first one, 1 dot. The next one how many dots? 3 dots. The third one, 1, 2, 3, 4, 5, 6 dots. So the patterns have triangular, equilateral, triangular patterns. So we can draw how many dots? Again, 4 dots we have to draw. Let's draw 1, 1, 2, 1, 2, 3, 1, 2, 3, 4 dots. So all this sum add up to how many? It's 10. Okay? So the next two here 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, and last row it's 5. So the total 15. The patterns are arranged in equilateral shapes. The sequence of numbers formed by the dots is called triangular numbers. Why are these numbers called triangular numbers? So they are called triangular numbers because the dots can be arranged to form an equilateral triangle. So we can write here, dots can be arranged to form an equilateral triangle. Next question, can the number 10 be represented as triangle of dots? If yes, draw it below. Yes, you can draw it here as the pattern of 10. As shown above, 10 is the fourth triangular number. You would draw it with the 4 dots on the bottom row, 3 above that, then 10, 2 and 1 at the top. So you can draw triangle of dot. This you can do by yourself. Okay. Next, draw the next 2 shapes in the given pattern. Write the number of dots used to draw the shapes below it. Here the patterns representing arrangement of perfect squares. So the first one, can write here 1. How many dots are here for next? It's 4. Here 3 and 3, that is 9. So similarly here we can write here next perfect square. How many dots? 4 into 4. 4 into 4, 16 dots we have to draw. How to draw 16 dots? Very easy. First draw 1, 2, 3, 4 here. Here also 1, 2, 3, 4. Then fill all the part. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It's a 16. So it's a shape of a square. 4 into 4, that's a perfect square. Arrange the dots in the manner of 4 into 4. Okay? So similarly, the next one, it's 25. 5 square, that is 25. So we can arrange the dots like 5. 1, 2, 3, 4, 5. Here also 1 over here. 2, 3, 4, 5. Then we can fill it 5 dots. See? Now we can get the perfect square 5 into 5. That is 5 into 5, 25. The sequence of numbers formed by the dots called square numbers. Why are these numbers called square numbers? They are named this because the dots can be arranged in a square shape where the width and height are equal. So mathematically, they are the result of multiplying by an integer by itself. So you can write here, dots can be arranged in a square shape. Okay? So today we learned how geometric patterns form triangular and square numbers. Also, we studied about patterns and missing numbers. Keep practicing and we'll see you in next time. Okay, thank you.